when I present this and when I write about it, we do always say, essentially, if we have a subduction zone earthquake, effectively all bets are off. And the general assumption on our coast is that communities like Nia Bay that are uplifting fairly rapidly would be subject to considerable subsidence during a subduction zone event. So that obviously would change their relative sea level rise pattern instantaneously. And you can actually see this in tide gauge data from, for example, Kodiak, Alaska, or even San Francisco associated with the 1906 earthquake, where their relative sea level rise patterns measured changed instantaneously and dramatically. So we would expect a similar thing to happen for all or some of these communities. Unfortunately, we have no way yet to model it. Now, one thing that I would like to head towards is a multi-hazards assessment. Now that we have sort of these full probability distributions for sea level rise, we could conceivably integrate them probabilistically with estimates, probabilistic estimates of large earthquakes and tsunamis and subsidence events to create these really interesting and potentially meaningful multi-hazard probabilistic maps for communities. I think we've got some steps to take before we can do that well, I guess I should say I don't know yet enough about how reliable the probability distributions are for things like large earthquakes or tsunamis. So I've got some work to do there before I would be comfortable doing that. But certainly these fully probabilistic sea level rise assessments allow for that.
Awesome. So quick question here. Generally speaking, what's the cost of doing a customized analysis for a community sea level rise assessment like this?
So that's a great question, and the two projects that I mentioned here